So as I said, today it's my great pleasure to introduce Jacque Benitez. So Jacque got her bachelor's in astronomy from San Francisco State University. So she's also a Cal State student like myself and the rest of you. And she's now an education specialist at the Academy of Sciences in San Francisco. So she'll tell us today about what it's like being an educator of science. So welcome, Jacque.
Thank you, everybody. I'm really excited to be joining you all. Just a little overview of what we're going to do today. I'll tell you a little bit about my history, how I got to where I am, and then talk a little bit about that connection between different science disciplines and how I've used that, my physics degree, in talking about engineering and even biology during my time here at the Academy of Sciences. And then also, we're actually going to kind of dive into what it kind of looks like to do science education and the things that I've learned over the time. So I'm actually going to be running through one of our virtual programs with you all. So I do appreciate as much participation during that time as possible. So you will be doing stuff today. So a little bit about me. As Alex said, my degree is in, it's a physics degree with a concentration in astronomy from San Francisco State University. And I got there kind of not knowing what I was actually going to do. I was actually undeclared when I went to state, and it was astronomy that really brought me into the physics realm. And I was really curious about astronomy, what I saw in the night sky. And I was reading some of your, what sparked you all into astronomy or into physics. And a lot of these were resonating with me as well. The fact that you took a physics class in high school and you enjoyed it, and so you wanted to pursue it. I kind of had the opposite effect. I had a horrible physics teacher in high school and was like, I know I should be able to understand this. Why am I not understanding this? So that's what got me into there. Love of math. I'm definitely right there with you all. And it's a lot of fun to be able to read what sparks our curiosity, because it is that spark that starts our curiosity, and we want to kind of go into, and if you don't have a passion for it, it's hard to be motivated. So thank you all very much for sharing those stories with me. So after I graduated, I knew I wanted to go into education, but I wasn't quite sure where to go. So as many people who get their degree, I went to Pete's Coffee and Tea to help me go along and make some money while I tried to figure out what I was going to do with this. I wasn't quite sure I wanted to go into a traditional school setting, being a physics teacher or even a science teacher. But I was lucky enough that a fellow friend and I would say probably co-worker, because we worked in the observatory together at SF State, was working here at the California Academy of Sciences, and he was working in the planetarium, and I was excited. They were going to be hiring, and so I got a chance to actually get a job here in the planetarium. And so that was my first diving into what does informal education actually look like. And in that setting, it was a typical lecture style. You are in this big dome, you're talking to people, you don't get interaction. And so that's what I thought science education was just sitting there and talking to people, and they were gonna listen, and then they can absorb that information and then move on. But as I was starting to explore working in the planetarium and doing these presentations, I realized more and more that I wanted to kind of dive into getting some feedback, getting our audience to think about these things, pause and reflect. And that's when we got an opportunity to go into another type of venue, which is called Hofeld Hall. And it's a smaller venue where it's a little bit more intimate. We have a big screen right behind us, but I can actually interact with my audience. The audience is right there in front of me, and I can ask them questions. I can get them to start noticing the things that are up on the wall behind me. And that's where I started to see those sparks of intrigue from just the little ones who were in there and seeing the stars for the first time, especially if they were San Francisco natives. We have a lot of fog, maybe not see the stars as much, but also our older audience asking inquisitive questions. And so that kind of got me thinking about, what does it mean to be a science educator? For a very long time, I thought it was just sitting there and talking to somebody, but it looked a little bit different in this setting. And so I was fortunate enough to then get an internship here at the Academy to start exploring this virtual learning experience. And that's where I got the opportunity to dive a little bit deeper into the pedagogy of learning and what does actual learning look like. So to kind of, did you have something, Alex?
Could I ask a question? Wait,
sure.
So was that before the pandemic started?
Way before, actually. Okay. This was about 6 years ago now. So the Academy of Sciences has been doing virtual field trips. You might have heard it as distance learning. There are a lot of different names for it. And I was lucky enough to be on the ground floor of that program starting. And that's what I've been doing the last 5-6 years of my career. Is I get to virtually interact with students. And for a long time, it was just one class on the other side. They had a camera on them, I had a camera on me, and we got to talk back and forth. And then the pandemic hit, and we had to shift our ideas of what that might look like, because now not only we wanted to reach out to those students and we had the background of it, but we had 30 different faces looking at us now, 30 different mics we had to figure out. And so I'm going to show you a little bit of a taste of what that kind of looked like before the pandemic and how we've shifted. And I think also shifted for the better, because we're able to bring in some of the learnings that we've gotten of how somebody actually learns. So with that, I'm going to switch over to kind of teacher mode with you all today. And we're going to run through one of the programs that we got to do a little bit before the pandemic, and now we're tweaking it a little bit more. It's called Impacts in the Solar System. So we'll get some fun exploration of astronomy here. All right, so want to welcome everybody. We're really excited. So while we are kind of getting ready and kind of thinking about things, I want you all to think about, what does it mean to be an astronomer? So I want you to think in your head, and then if you want to use that chat box, you can let us know maybe one thing. What does it mean to be an astronomer? All right, thanks so much. So astronomers do a lot of different things. They are able to explore, make observations. They may use tools to help them with that, such as some of these tools right here that astronomers are using, like telescopes, even rovers. And sometimes they actually do look at Earth as well and think about what is Earth like. And then maybe think about what that means outer space as well. So today, you all are going to be astronomers with me. And we're going to explore this question of, are all things in our solar system affected by impacts? And so I want you to think about that question for a little bit of time. And now I want to go ahead and have you all use that Mentimeter one more time. 1 second. And I have an image. I want you to think about, what do you notice about this object?
Are we supposed to be seeing an object?
You should be. Oh, 1 second. Thank you.
You bet.
Important. Still working on using this tool. This is a new tool for us. So there you go. You should be able to see it now.
Yeah, so make sure to click on the link in the chat.
Yeah. So if you click on the link in the chat, that will take you to looking at that object. All right, so we're getting some great additions, what we're thinking. And this is a word cloud, so every time somebody puts the same one, the word's gonna get larger. So we see craters, kind of those dome-shaped areas. We see that it's gray. Kind of a weird oblong shape, so it's not perfectly round. Oh, alone. I like that. Kind of like a potato. I get that a lot from students. Looks like a potato. Now I'm curious, does anybody want to share out? And you can go ahead and unmute yourself if you'd like. What does this remind you of?
I'll just say whoever put potato was on point. It definitely looks kind of like a potato. Wasn't me, but whoever put that.
It looks like a miniature version of the moon.
Ah, yeah, we got that. Thank you. We also got that in the chat box that it kind of looks like a squashed or smaller version of the moon. Yeah, it definitely reminds me of the moon as well, because our moon has craters. We can see the side that we normally look at, but we also look at the other side of the moon, and that kind of looks a little bit even more like that object that we were looking at. And so we can look a little bit closer for evidence of other impacts when one object hits another. It might leave an area, it might not. So let's go ahead and we're going to look at a couple of different objects one more time. And so we have object A, object B, object C, and object D. And go ahead in the chat box, just let us know kind of what are some of the things you notice about these three objects. All right, thank you so much, everybody. So this is kind of our first notices. As scientists, it's important to make our first notice. The next question I want you to think about is, do you see any evidence that these objects have been affected by an impact? And go ahead, you can either use that chat box, or if you like to unmute yourself and share out loud your ideas.
C and D look impacted, but A and B aren't quite so obvious.
All right, so we're seeing kind of those craters like we saw earlier on C and D, but A and B might not look as obvious. Anybody have another idea? Or
I would say A and B might look like they were once a part of something, but not necessarily impacted.
Okay, so you think maybe it kind of broke off of something?
Yeah.
All right.
Or maybe were ejected during a collision.
Ah, or did came off during the, great, thank you so much. So we can kind of look a little bit closer at these ideas. And one thing that helps astronomers is to think about the size of the objects when we're looking at that. Now, if we were just looking at those objects, could you tell really how big they are? No, they kind of just look like rocks right there. So one thing we do as a scientist is we use a tool called a scale. So it's a measurement tool that helps us compare things. And so to do this, I am going to give you all a little scale activity where you can see these objects overlaid onto a map. And you can kind of figure out how big they are based off of that. So in the chat box, I just placed a link to a Jamboard. It'll prompt you to copy this Jamboard. Go ahead and copy it. And this is your own one. So you get to play around with it. You can move the object over the map.
It seems to require a Google account.
Oh, yes. So if you don't happen to have a Google account with you, I will go ahead and place the first one on the screen as well. So this is our map. This is our first object we're going to be looking at, object A. And this is a map in San Francisco of Golden Gate Park. In fact, you can see the Academy of Sciences is right there. That's the building I'm in right now. And then we have some baseball fields. We have a track field. So you can kind of have an idea of how big those are. And then if I place our object on top of that, we can start to have an idea of how big this thing is. So if you are comparing this object to this map, how might you measure it? Would you measure it by blocks?
Blocks would be good, although we know that the one side of those blocks are a lot shorter than the other side. Long blocks and short blocks.
Exactly. So we might say that it's probably a couple, probably 7 or 8 short blocks. Sorry.
Did you have a comment, David? I think we sort of missed it.
Oh, I just typed, I was thinking football fields are traditional, right?
Yeah, totally. There's a football field right there. That's Kezar Stadium. That's where the 49ers used to play a very, very long time ago. And so you can compare that. It probably is about maybe 4 football fields long. I actually like to turn it on its side, and it's about the width of Golden Gate Park. And I walk across the park every day for work. And it takes me about 20 minutes to go from one side to the other. So if I could walk on this type of object, I know I would take about 20 minutes to walk from one side to the other. So I have kind of a better idea of how big these objects are. So we can do the same with our other objects. So we're zooming out, we can see San Francisco. And for those who have the Jamboard open, you can tab over to the next slide. And you can play around and see how big this one is. And then we can go even further out and see the Western United States. You have an idea of how big California is, maybe Texas, and compare our objects to those. So as a scientist, we can start to have an idea of how big these things are. And we can start to think about maybe we see more craters on the bigger objects and we're not seeing craters on the smaller objects, which is kind of interesting. And so we can kind of go through, and this program continues on. We actually look at the example of Jupiter and looking at impacts on its surface, and realize that some evidence actually disappears over time because of Jupiter's surface. And so we use the example of Shoemaker-Levy 9, a comet that came close enough to Jupiter that it broke apart and actually impacted, and we knew ahead of time that this was happening. So we actually have images of that impact, which is really cool. And so at the end, we get a chance to reflect on what we actually learned in the program. And we asked them to think about that question at the beginning of, are all objects in our solar system affected by impacts? And I asked them to give me evidence of why. So throughout that time, I used a couple of different types of learning activities to help you explore this idea. We had the options of sharing out loud, talking throughout the time, use of the chat box if you wanted to do that as well. If you had the opportunity to use the Jamboard, you actually got to physically move things around and you got to play around with your own ideas. Now, normally I would give you a lot more time to play around with those ideas. I just kind of condensed it down into what I thought was appropriate for this group. And so we got a lot of chances to do different things. Now, also being able to, sometimes I will actually create a breakout room so students can actually talk about what they see. And so there's a couple of different types of learning that I've explored with the Academy of Sciences and with a program called Reflecting on Practice. And this is an opportunity for us as informal educators to explore these ideas. And the three main things about how people learn is we want to connect our prior knowledge of things. So for example, I started off talking about an object that kind of reminded you of the moon. And we had that connection of the moon and what we've seen of the moon. And so you already kind of had that idea of craters and impacts. And so I wanted to bring that in with this new object. Conversation and learning is social. We've been able to talk a little bit. If I had an opportunity to actually be in the classroom, I would make sure and be able to have a lot of people talking together, whether it's a partner sitting next to you or maybe a group discussion. And that's really important. And then engagement and different types of engagement. So hopefully at the beginning of the talk today, I kind of started on getting your emotional engagement with thinking and reflecting about what sparked that curiosity in physics. And then also got you moving and actually doing things if you happen to have that Jamboard. And then also just that cognitive engagement, kind of that aha or that, ooh, that kind of looks interesting moment. So hopefully you got a little taste of kind of how myself as an educator have kind of grown and figured out these different types of learning styles. And so I'm really excited and I love the idea of being able to talk to students virtually. So before the pandemic, we used to do a lot more of that conversation and that social interaction. And that's one thing I have seen is that that has gone down in the time that we are in right now, because we're kind of in these own little silos and there's not opportunities to maybe talk to somebody who you don't normally get to talk to. So that's a struggle that I've been having, is how do we continue to put conversations in this time? Now for us, we only get to see students for maybe 30 to 40 minutes in that chunk, and then we're gone. So we try to build that in right now in conversations that they can have in their class before our time or after our time, where they might actually be able to start having those meaningful conversations. But we're still trying to figure that out. It's always a learning opportunity for us. And so we got a chance to kind of think about what that means and kind of reflect on that this year. And so these new tools of using that Mentimeter to get student voices heard, to see your interaction has been really helpful. Also using the tool of the Jamboard, that's brand new. I just started using that this past 2 weeks. And it's been a lot of fun as well, and I'm excited to see that. So we get to explore learning a lot. Now I want to shift gears a little bit to kind of how I used my physics degree and brought it into this world of natural sciences. Because the California Academy of Sciences, although we do have a planetarium, really focuses on the natural world. And so that was a huge shift for me when I got into this position. But I do believe that when I had an opportunity to sit and think about what did I learn in physics that I can apply to these new learnings, I learned that we are able to explore, observe. Those skills that you learn can be transported or transferred, into those different mediums. And so I've been able to use those in exploring, for example, this beautiful skull that I happen to have right here with me today. And I'm gonna go ahead and try to spotlight myself so it's nice and big. But this is a mystery. And a lot of physics and a lot of astronomy is looking at something kind of unusual. And this one is kind of unusual because it's kind of purple. And so I can take those principles of physics, making observations, thinking about the bigger picture. How does this animal connect with its ecosystem? And I can start to unravel and look at clues to help me figure out why this skull is purple. And including actually the teeth. If you see at the very top of the teeth, it's actually purple as well. So I am ecstatic that I get to explore these different sciences. I came into this job thinking that I would only be teaching astronomy. I didn't think any of the other sciences were as interesting, but there's so many mysteries to solve now that I've kind of opened up my eyes and been able to explore these ideas that it's been a lot of fun. And I've definitely started geeking out on a lot more different things, which has been a lot of, been cool. But I wanted to open it up for any questions that might have kind of popped up during this time.
Maybe not a question, but an observation or experience. I took a math class at Sonoma State from somebody who at the very beginning of each topic would reach all the way back to kindergarten or something. And it wouldn't take more than a minute to bring it up into, differential equations. And then each day would again, like start back to the beginning of the topic, just to spend a minute. Everybody has the same context. And I learned so much, and I so much enjoyed that class that even though it wasn't my major, I took every class that I could that professor taught, that would fit into my schedule. Every semester I'd do my schedule, and then I would say, oh, I wonder if there's a class that Tom is teaching that fits my schedule. So it really is powerful.
That's awesome. Yeah, I've been listening to a new podcast, or it's not very new, it's about a year old, called Shortwave. And they've been starting a series where they go back to high school and look at different high school science principles or theories, and kind of go back and say, okay, this is what we learned, but let's dive a little bit deeper. And it's a lot more fun if you have that connection, or you think about, okay, what did I already know about this subject? So thank you so much for sharing.
I was wondering, working at the academy, what would be your favorite aspect of the job, but also what would be your least favorite aspect of the job?
I think the favorite aspect of the job right now is talking to students. Actually seeing them has been great. I love being able to hear their curiosities, and for example, looking at that asteroid, I get so many different things. Potato, I get sometimes one of the other asteroids, Ichikawa, I get looks like a peanut, and it's a lot of fun to see what their imagination has, as well as I think one of my favorite things is I get to actually talk to scientists as well. We're not only just a museum, but we are a science institute. So we do have scientists working on different projects. And so, for example, one of my projects this month is to talk to our collections manager of mammalogy and ornithology and get to talk to her about her job and help figure out how to relay what she does into what students can understand. And so that's actually why I have this mystery sea otter skull with me today, because we're doing a whole program on figuring out what that animal is. And we have a whole story behind it, and it's really fun. So I'm excited. It starts tomorrow, so been prepping for that. Least favorite, I think, is probably right now the amount of time I have on the computer. And while I've been doing virtual teaching for the last 6 years, it's getting a little tiring of doing it all the time. I miss actually being in front of students because I do have the ability to actually do hands-on learning science experiments with students who come to the Academy on field trips as well. But my main job is doing the virtual. Are
you gonna tell us why the sea otter is purple skull? Do we know?
Oh, okay. So what are some ideas why the sea otter is purple?
Some permanganate.
All right.
The amount of sea urchins it eats.
Oh, maybe it's diet. Any other predictions? So we do see that.
I have one.
Yeah, go for it.
Okay. In my pool, things are purple if there's an excess of copper or one other element, which I think is manganese, but anyway, an excess of one element.
Oh, that's actually a really good idea. Excess of elements as well. Well, if we look at the teeth, there definitely is that purple. And it turns out that something in sea urchins, and this is actually quite interesting because scientists really don't know why this is happening, but if a sea otter eats too much or too many sea urchins, it'll turn its bones and its teeth purple. So that's something that we get to explore, is actually looking at its diet and figuring out that one of its food items is a sea urchin. And so that's what's causing it to become purple.
Is it the Japanese make ink out of kelp or something? Or
I know they do use the sea urchin. I don't remember if it's actually, it might be ink. Because I've also heard anecdotally that people who sometimes get stung by a sea urchin or step on a sea urchin, that area actually gets kind of purpley color. So it's kind of interesting.
Is eating too many sea urchins a disease condition? When you say no, or you just mean when it eats enough, then it gets purple?
Yeah, if it eats enough. Something that I've learned is that just like us, sea otters also have favorite foods, and one can actually be sea urchins. And if there's abundance of sea urchins available in that ecosystem of that animal, then it will eat a lot of it.
So changing the topic a little bit. So at your job, so I know you said you touch on lots of the sciences. So do you really get to span all of the different fields of science, or do you specialize in certain things?
We try to specialize in the subjects that the Academy is known for. So rainforests, we do have the opportunity to dive in a little bit to astronomy with our planetarium. We have coral reefs is a big thing for the Academy as well. And California and California ecosystems are kind of our main focus right now. And so those are the main places that we get to, but every once in a while I get to dive in to another subject. So for example, about 2 years ago, we wanted to do a program that was San Francisco based. And at that time was when the city was really talking about their new seawall. And so we got to create an engineering program where students are engineering a new seawall for San Francisco. And so got to dive into what does that look like, and got to bring out my waves and principles. And so that was nice to be able to kind of look back like, okay, what does it mean for waves to hit an object, and how will they react? So that's been kind of fun. What else have I dived into? Chemistry is a little bit not the specialty of the Academy. So we tend not to dive into that a little bit, but biology is the big one as well.
What does the astronomy program at the museum do?
So we have a couple of programs running right now. The one that I showed you that are impacts in the solar system, to really kind of explore that. So we get a chance to kind of explore a little bit of the lesser known objects too, those asteroids and dwarf planets that we got to see. And then we also got a program that looks at the different spheres on different planets. So we start off with planet Earth and look at the hydrosphere, the lithosphere, the biosphere, and then take that idea of going, having spheres here on Earth and looking at different planets, and looking at those and what's lacking, what's there, what's not, and also magnetic fields. So and then we kind of put it in the lens of actually going into, could there be life here? So that's definitely a big thing for students. So those are kind of the big ones that we have. We've been playing around with a new program where we have students watch a planetarium ahead of time, and then we do a question and answer time for any questions that the students have after watching the planetarium show, which has been really popular, especially because all the students want to know what is a black hole and what will happen if the Earth gets near a black hole. So that's been fun. Yeah.
I used to teach with demonstrations, and interactive demonstrations were especially fruitful. The trouble with them in a museum setting was that the demonstrations tend to be overused and go out of repair. And so you tend to keep them very simple. Mm-hmm. And but still, if when people come back to the museum, if you could, well, for example, one very easy one is a fluorescent rock, and to shine different colors of light on it, and sufficiently violet, and it should fluoresce. So you want to pick your rock and pick your mm-hmm. colors. But if the viewer can then manipulate the spectrum to shine, to cause the rock to fluoresce or not, that's pretty simple and may not attract more than a very young student. But still, if you could think on what would be good to have as an interactive demonstration for your particular subject.
So one thing we've been playing with demonstrations, or if we bring, for example, some specimens onto the floor, we really start off with trying to ask them, ask any of our audiences, whether they're small or big, to first think about what they notice, what it reminds them of. So you're starting off that conversation again with trying to connect to that prior knowledge. And then what we've found is that we can do some demonstrations like that. I know our astronomy demonstrations have been looking at different light sources and how that changes. They use it in a dark area, and I believe that they're doing something with actually looking at different light sources through I don't know why this is, totally out of my mind right now, but a source to be able to figure out what type of light it is. And so that's been something that they've been playing around with. Now in this day and age, I know they're trying different things of being less hands-on, unfortunately, with those demonstrations, and more of having the person who's doing the demonstrations manipulate for our guests. So while students don't actually, or people don't actually get their hands on things, they can still direct our presenters, or if we ever get docents back, to be able to do things and ask them to flip things over or look a little bit closer. So I believe that's kind of where we're going with demonstrations at the Academy.
Thank you.
So for students in the audience who are interested in potentially following a similar career trajectory, going towards sort of science education outside of K through 12, what recommendations would you give them? Like, so I know, of course, getting their bachelor's degree in physics or astronomy or related fields, but are there any internships maybe through the Academy or any other types of experience?
Yeah, I think just seeing any chance you get to do some working with different audiences. I think the biggest thing that I have learned, and that has been a great tool in my wheelhouse, is being able to pivot and depending on the audience that I have in front of me. And so also those improv skills are really helpful. And we used to have internships here at the Academy. I'm hoping that they'll come back next semester. So that way we can get more opportunities for informal education, whether it's virtual or actually in person. We'll see. It'll all depend on that. But I know there's a lot of amazing places, like the Exploratorium has their explainers. I know that tends to be on the younger age, but sometimes you have an opportunity to do that, as well as the Bay Area Discovery Museum does great work with younger students. So that's a really cool place. And I know they do internships as well.
You know, so are the internships like at the Academy, are they for after you have your degree, or could they do it while they're still working on their
so the ones with our department, which is called Student Education, because we work directly with students, it can be during your degree as well as after your degree. And no degree is required, although some scientific knowledge is helpful. And so in that internship, what we do is we ask you to be available 1 to 2 days a week during school hours. So it might work, it might not, depending on your class schedule. And we bring you on to learn some of these types of pedagogy that I kind of talked about today, as well as be able to start teaching along with us. And what we do is we actually co-teach. It's rare now that I just teach by myself. I tend to have a second co-teacher with me virtually. And we get to talk back and forth. And so in that internship, you would be with a co-educator and learn how we explore different sciences. And then also the opportunity to explore virtual learning as well.
Now you stopped the internships, not because of funding, but because of COVID?
Yes, so it was interesting because this year we took as like, this is our testing year. We're trying crazy experiments with what virtual learning can look like. We started off the semester with trying these 3-part series where we have students join us 3 times within a month. We've been experimenting with these live streams where we broadcast out on YouTube Live to many classes at once. And so because we were very experimental this year, we made a choice of that we weren't going to bring on any interns, because we were making up all this stuff as we were going along, to tell you the truth. I was creating my PowerPoint slides the night before. I was doing video editing the night before. I'll be doing a little bit of video editing tonight for my program tomorrow. So because of that, we weren't able to prepare our interns as well as we thought in our normal internship. So that's why we put a hold on it this year. I'm hoping next year we have a better idea of what this space looks like and we can bring on those interns. David, do you have a question or a comment?
Yeah, I was thinking about something you said about, you have to field all kinds of wild questions and you have to be able to pivot to respond to your audience and your improv skills, things like that. And I was wondering if that just sort of suited your personality, or is that stuff you really had to learn over the years?
Oh, that's something I had to learn. When I first started the planetarium, my interview was horrible. I have horrible stage fright. And I am lucky enough that I had that friend who vouched for me that said I would do great. And it's been slowly building since then. I had to learn how to be energetic. I am an introvert. I tend to like to be quiet. I'm a quiet person. So this big boisterous person you see right now is my educator. This is a personality that I have now, and is my Jacque as the educator. Definitely had to figure out how to say it and be okay with saying, I don't know. That was a big one as well, because my tendency was I'm just going to ramble as much as possible to fill the time, and hopefully maybe I'll get there. And maybe this is the answer, but I don't really know. So here's your answer. Now I'm able to sit back and kind of think about, okay, let me think about my science knowledge. Let me verbalize my thought process with you. Okay, I know that this sea otter, its favorite, it eats a lot of different types of food. It eats kelp, it eats sea urchins. Well, wait, a sea urchin is purple. Maybe it has to do with its food, but I don't know. Maybe that's something we can explore a little bit more. So Yes, it's definitely a skill that I've learned over time, and it's still a skill I continue to practice. And there's definitely times where I've been caught off guard and I haven't been as fast as I would have liked to be. For example, last week I had a program where I was expecting one class of 22 students, ended up with 3 classes of 66 students. I didn't pull my tools out fast enough to realize what was happening. And I went out of that program realizing, okay, where was things that I could have done to accommodate that many students? By the way, it was first graders. And so it's just trying to remember those tools that you have and bringing them out as fast as possible. And sometimes you have it and you're on your A game. Other times, you try your best.
All right, so it's just now almost 5 o'clock. So maybe if there's one final question, we could try to squeeze it in. But if not, that's okay too, because it's almost time. All right, well, if not, then on behalf of everyone, let's thank Jacque. Thank you so much for that wonderful talk. It was really great to learn about what it's like to be a physics educator or science educator.
If anybody is interested in diving a little bit deeper or wants to know about that internship, feel free to email me and I will be putting my email address in there. So thank you so much for having me, everybody.
Thank you.
Thank you.